So Eric, you are the general manager for Meneta North America. Is that right?
Yeah, correct.
All right. So let's start off. So why don't you tell me a little bit about, I guess quickly, who Meneta is, and I guess who your target customer is.
Okay, so Meneta is one of the big four in the world for brake shims and backplates. So we design, we test, and we manufacture brake shims and backplates for the OE and the aftermarket.
Got it.
Globally, we have facilities in US, in Europe, in India, and in China. And we have technical centers and dynos in US, in Europe, India, and China.
Got it.
We probably sell to all the OE and aftermarket customers that you may think of, including brake suppliers, friction suppliers, or OEMs. So pretty much all of them.
Got it. And is your business primarily the OE, or is it pretty even aftermarket OE?
Well, it's we have a big aftermarket business, but we're very driven on the OE side. So
got it.
But my goal in US is to grow both, to grow the OE and the aftermarket business.
Got it. Yeah, and your role as general manager, is it pretty balanced between the sales side, like commercial side, but also maybe the technical or operational side, or is it heavier one or the other?
Well, we have I have two locations here. So we have a location in Michigan where we do sales in engineering. That's where I'm located at, and I also have a plant in Jackson, Tennessee.
Okay.
So Meneta North America, which we call MENA, is still pretty small. So my main focus today is to try to grow the business. So I'm focusing a lot on the sales side and engineering side, supporting customers, testing, engineering, fixing noise issues, so we can grow the business.
Got it. Got it. And as far as your background too, so you've been in the brake NVH world for several years now, right? So how did you get your start in the industry?
I started, let me see, a long time ago, and I think in 1993, after I got my master's degree in NVH, my first job was at Ferrodo. I don't know if you know the Ferrodo brand in Europe was very famous for brake pads.
Mm-hmm.
So I studied in 93, and then in 96, I moved to the US for Ferrodo. Then Ferromogel acquired us in 97, 98. Then I moved to a company called MSC. I don't know if you remember, Material Sciences Corporation.
Yeah, sure. Yeah, they were later bought by, was it Wolverine maybe?
Yes, exactly. So I moved there. I stayed there 12 years. So I worked in the, I was NVH technical manager, and I moved to a global job. And then after a few years, I moved to a VP position in charge of sales and engineering for brake shims. Mm-hmm. And then in, what year was that? 2014, Wolverine acquired the brake business from MSC.
Yeah.
So I moved with the brake business for a couple of years, worked in sales, engineering, supply chain. And then earlier in the year, this year, I just joined Meneta. So I've been to MSC, Wolverine, Meneta. So I've done almost all the brake shim suppliers. I'm just missing only two, I think, in the world.
Yeah, no, for sure. Yeah. So you were originally from France, is that right?
Yes.
Yep.
Yeah.
So you were still fairly young when you moved to the U.S. So was that an easy transition, or was that tough? What was it like?
It was. I always wanted to move, so it was easier if you want to do it. It was not easy for probably a year. You know, you have no friend, you have no family, you work a lot of hours. So I think it was not easy, but especially for my wife. You know, it just she was alone with a baby, but she thinks that was the right move now. So she's home now.
Yeah,
I think that was a right move, but not easy. For sure.
Got it. So have you been in the U.S. since 1996 then, every year?
Yeah, every year, yeah.
Okay, got it.
Yeah. So 23 years. So
got it. So when you hear the word football, do you still think of soccer, or are you
No. It took me a few years to like the American football, but I really enjoy that, especially college. So
Got it.
You know, I still like both soccer and football.
Yeah,
Yeah.
got it. Cool, good. So talking about Meneta, so you and I, we kind of had a brief discussion not too long ago about, the drive to zero noise. So let's talk more about that. Can you kind of tell me kind of what that is fundamentally, and like I guess Meneta's take on kind of that initiative?
Yeah, for sure. Well, when I go back 5, maybe 10 years ago, you had to do a shim optimization or brake pad optimization for noise, and the target was 5% noise. You know, out of a total number of stops, if you get 5% noisy or below that, you're fine. So that was the easy way, but you don't know that when you do it. But now, so 5%, and it came down to 4, 3, 2, 1, and basically lately in the US, I think pretty much you are almost at zero. So if you get a few noisy stops at the same frequency with a potential to get more, so you have to work on that. So pretty much right now, what we're shooting for is no noise.
No noise. So does that mean like literally 0 decibels, like nothing?
Well, it's not 0 decibel, it's zero hits above 70 dB. But now some of the OEMs or brake suppliers are even looking at 60 dB and 50 dB. If you cannot hear anything, it's 0 dB. You know, threshold of hearing is 0 dB. So,
Yeah.
but 70 dB at the wheel means about 50 dB inside the cab. So it's pretty much our target is to get to zero noise. So it's creating a lot of challenges because it's, first of all, there's three things. First of all, you need to be able to reproduce the noise on a dyno, and I think the industry has done a great job improving the correlation between vehicle testing and dyno testing in the last 5 to 10 years.
Mm-hmm.
We're still missing. Sometimes we get noise on the dyno, we don't get it on the vehicle, or we get noise on the vehicle, we don't get it on the dyno. It still happens, but it's much better than it used to be. So first of all, you need to get the noise. Then you need to have people, expertise to analyze the noise, so you can think about solutions. So you need NVH engineers, people who know about brake shims. And these are very difficult to find in the industry, as you probably know, being a recruiter.
Mm-hmm.
But I think at Meneta, we probably have one of the best technical experts you could find, especially for brake noise and shims. So I'm very, very happy with that. And then, so when you have the expertise, then you need the products. If you don't have the products to fix the noise, for us it's shims, then you won't get the business. You won't fix the problem. So Meneta in the last few years have been really focused on products, because it doesn't matter if you reproduce the noise, if you can't fix it, then you're going nowhere. So Meneta has decided to refocus on new products, and specifically for cold noise. And so cold noise, why? Because this is one of the toughest noise to fix, basically cold noise, because you get a lot of low damping in the system, you get a lot of high friction, a lot of energy in the system, and there's not much damping in the pads or the disc or the caliper to fix that. So it's a challenge. So we've been focusing on that. And the other thing, with electric cars coming, everything is so quiet. The operating temperatures are much lower than for an ICE car, so a lot of the noise will be at the lower temperature side. So that's why we decided to do that.
Got it.
The other challenge is for electric parking brake. You know, every car now has an EPB. These brakes generate a lot of pressure, like 160 bar, and basically damaging the shim. So if you don't have the right shim, you could still fix the noise, but after a few days of applying the EPB, the noise would be back because the shim would be damaged. So it's another area where we focused on designing specific shims which are very durable under very high pressure. So these are the challenges.
Yeah, no, interesting. So like over the years with kind of working in this space, so has the material changed a lot over the years as far as kind of what makes up of the shim, or is it more of the design of the shim working with the pressure plate and the friction, all that kind of stuff, or is it a little bit of both? Is it kind of a mix of everything?
I think the shim constructions, if you look at the shim today and 10 years ago, they look very similar. You get rubber, you get steel, you get adhesive, you get constraint layer, you get double sticky. I think what changed a lot is the nature of the rubber, the formulation of the rubber, to try to have better damping performance and more durability, and the adhesive layers, because the adhesive layers what provide you the damping of the shim, damping of the vibration of the brake pad. So all these layers, the layers being used to basically bond the shims to the pads, have been optimized for various temperature conditions and durability conditions.
Got it. And I guess to make matters worse, well, not really, that's not a good way to put it. To add more challenge to your business, obviously the introduction of the EVs to the market obviously adds another wrinkle, right? Because I mean, I've never owned an EV. I've never actually driven one, but I do know that they're really, really quiet, right? There's obviously no traditional engine under the hood. So it's really quiet. So unless the person's got the radio on, I mean, it's really quiet. So obviously the drive to zero noise obviously is great, since you're almost, it keeps improving every year. We're getting better at the technology advancement testing. But has that affected your business on how you go about it, or is it still kind of the same approach, even with this?
Well, it's the same approach, but I think we're focusing a lot more on the low temperature side. So because of EV, the way you use the regen braking all the time, so you don't use the brakes much. You use them a little bit, but the temperatures are much lower than when you have an ICE car. So I think that the focus is really on the lower pressure, the lower temperatures side of things. So that changed the way we design new products. That's really the focus. And because it's so quiet, I think the OEMs now are starting to look at 60 decibel, 60 dB, and I think it will keep going down 50 dB, because you're right, these cars are very, very quiet. There's no engine noise to hide anything. It's just it's nothing.
Yeah, you hear it. Well, I mean, I know. I mean, obviously the brakes are a part of it, but even like rattle noise and everything else.
Oh yeah.
I mean, everybody.
Wind noise. Yeah, you hear a lot of these things. You hear a little bit of everything. Yeah, that's true.
Yeah, everything. Wow. So getting back to what you mentioned earlier about, kind of being able to, like, from a testing perspective and development, being able to replicate the noise.
Yeah.
So, I mean, how does that work? I mean, because I'm trying to envision, what's the approach? Is there a structure or like a standard of saying, okay, this is how you go about doing, kind of trying to replicate the noise, or is it literally just kind of a little bit of everything and just guesswork?
No, to reproduce the noise, we're using specific noise procedures that have been refined year after year after year. One of the key ones that people are using is the SAE J2521, which was designed, it's a very famous SAE standard, designed, I think, in 2006.
Okay.
So that was based on the TRW noise procedure at that time coming out of Europe. But this is really a great noise procedure, which basically generates a lot of noise. You drag the brakes. It's a worst case scenario. So the last 5 to 10 years, people have been refining this J2521. Some companies have been using that, making it longer, adding more modules, like the OEMs. I think in US, for the big three, every noise procedure they're using for validation is based out of J2521, but it's longer. Instead of being 1 or 2 days of testing, now it's 4 or 5 days. So these noise procedures are getting longer and longer. So I think the correlation between dyno and vehicle testing, it's much better because of all these refinements, but we're still missing a few things. So as part of the SAE standard committee, I'm chairing the Brake NBA standards committee. We are looking at a new revision of J2521 to try to include more stops at low pressure, low speed, to try to include cold noise. One of the worst thing you can get is in the morning when it's very cold and wet. You typically get noise, cold noise. So the existing J2521 does not generate these conditions. We don't have that today in J2521.
I got you.
So one of the ideas of a few members of this task force is to add a module where we could have high humidity, cold temperatures to try to simulate these very specific conditions that you find only in few states in US, but they generate a lot of customer complaints. So, trying to refine this J2521. So we have a task force of, I think, about 15 people from OEMs, brake suppliers, friction suppliers, testing suppliers, Shims suppliers, and we met a few weeks ago, and we're going to start working on how should we make this J2521 procedure better for the industry. Because at the end of the day, you want to correlate with vehicle testing so you can minimize the amount of testing everybody's doing, trying to find a noise, not finding the noise. Because if you could find a noise, at least you could work on it and try to fix it. If you don't get it, there's nothing you can do about it.
Yeah. So how do you go about changing the like setting the standard? Like, is it like a really long process? Is it like a voting process? I mean, or does someone just literally just wave a magic wand and say, okay, here's the new standard, this is what we're going to do?
No, we typically we have a project. So we have a chairman for when somebody says, well, I want to work on, I don't know, this subject, and people agree in the committee, we set up a task force. We have a chairman, and we invite members to join. We talk to the industry experts. Like for this J2521 revision, I think we have 15 people. Okay. People who've worked in the industry for a long time. We have a lot of experience on noise. Mm-hmm. And then basically we draft a document. What we try to do is having something to be released in 12 to 18 months. Because we don't want this project to drag forever, because people would lose interest. You lose focus, you lose energy. So 12 to 18 months, we think is a good way to do it.
Got it.
And then at the end of the day, when we have the draft, we submit it for ballot, and then the members of the standards committee can vote, approve, disapprove, or if they have comments, things they don't like, they can write them down, and then we'll review them, try to modify if we agree, and then go a second time to ballot, and then the new procedure will be released. That's the process.
And is this going to be, is this like a global standard with this, or is this more of a US based standard, and then like Europe and Asia or whatever, they necessarily don't have to follow that practice, I guess?
Yeah, they don't have to follow that, but what we're trying to do to avoid duplication, because I don't want to have to run 3 different standards, one, because we're all global now. Mm-hmm. So what we're trying to do for all these standards now is to have people from Europe join the task force. So in this J2521 task force, we have people from Europe. I think we have people from ZF, we have people from Volvo, people from Audi, because at the end of the day, again, we don't have time to use 2 standards, and at the end of the day, they tell you the same story. You know what I mean? It's little differences. So what we decided to do when I became the chairman of this committee is to really try to be global, at least Europe and US, and have something that we could use on both sides of the pond, so we don't have to replicate standards. And so that's the way we work.
Got it. So, okay, good, interesting. So what's, I guess before we leave here today, what's the, what are a couple, I guess, projects, initiatives, what's next for Meneta right now, I guess specifically within North America? I guess it's continued to grow.
Yeah, I think we're very focused on growth right now. We as people probably know, we're fairly small in US. We're rather large in Europe now. We have a very good market share in Europe. We're growing in China. So one of the big markets that we haven't grown because we didn't put the focus on that is North America. But now we're really focused on growing, getting business. And then we'll put more manufacturing in Jackson, Tennessee when we need to. So that's really where we're focusing on putting more dynos. I know everybody's talking about testing and dynos, which I understand we need to do, but the goal of Meneta at the end of the day is to fix the problem quickly. So with good products, with expertise, so we don't have to run all these 50 or 100 tests to get to a solution. Not that sometimes you need to because it's complex. So sometimes you have very complex noise problems that you cannot fix in after 10 tests. So I understand some programs you would have to run a lot of tests. But for me, during my career, running 50 tests or 100 tests on a platform is not something to be proud of. But some people like that. I don't. I think the key for the industry is to go find a solution quickly. So it will be faster, it'll be cheaper for everybody, the OEMs, the brake suppliers, the friction suppliers. So it's a combination of good products, good people, expertise, and then and of course trying to reproduce the noise that you're going after. And then if you can do that, I think everybody would be happy, including Meneta. So
Yeah, got it. Good.
Big challenge.
Sure. No, as always. Yeah, no, good. Well, good. Excellent. Well, Eric, I appreciate it. It was good talking to you again, and I appreciate your participation today.
Okay, thank you.